Hi everyone, welcome to Vedantu J English. I'm Diksha, your chemistry master teacher. So everybody let me know in the chat box if I'm clearly visible and audible to all of you or not. And today we are going to do like very interesting topics, two very interesting topics. One is limiting reagent and the other is empirical formula, right? And I'll also show you that how based on these two topics, actually these topics are very easy to understand. There is a formula where you can actually know the steps and do the questions, right? If you actually see this lecture in depth, right, you do all the questions, right, then definitely you will not lose marks from these topics. And in the end, just give me a second. Yes, in the end, I'll also show you one JEE Advanced question, right? Usually students are like empirical formula, that is not asked in JEE Advanced, ma'am. Such a simple topic. 2022 JEE Advanced question, one sample I'll show you. So please don't ignore these two topics, right? Okay, so everybody, are you ready for this class or not? Yes, Jyoti, Abhijit, Taruna, Chandu, Rama, Raju, Abhijit, Mitra, how are you all? So are you all ready for the class, students? Yes, everyone. Yes, have you smashed the like button or not? Firstly, let me know that. Have you smashed the like button? See, last time I have not given you any homework, nothing, right? So today, take a chill pill. But next class, I'll see whether you have done the homework that I'll give you today, right? Okay, shall I start, everybody? Okay, so how's your energy? How's the Josh? I can't see your Josh in the chat box. I can't see your Josh in the chat box. Yes, everybody. If the energy is high, then spam this chat box with green hearts, right? Fire in the chat box so that we can start this class with full energy, full passion, full dedication. This topic you are going to do today, and you have to make sure, and I will make sure that you will not lose even a single mark from this chapter, from this topic, right? Okay, yes, everybody, perfect. Now let us start this. So starting with the concept of limiting reagent. Limiting reagent. So see, in limiting reagent, if you see what we are going to think, limiting reagent is, for example, okay, how many of you like rasam rice? Okay, how many of you like rasam rice? How many of you like idli sambar? How many of you like dosa sambar? Right? What's your favorite dish? Let me know in the chat box. Or ma'am, I don't like all of this. This is very normal for me. Ma'am, I like pizza, ma'am. I like burger. Okay. So whatever you like, what's your favorite dish? So I am assuming that you have this one burger, right? This is one burger, right? I don't know how to make it, but yeah, something like this. It will look something like this. And here you have one tikki, right? This is one, you can say patty, that we call tikki. This is burger. This is burger, right? So if you have one burger, one patty, in that burger you will put one patty and you will have your full-fledged burger, full-fledged meal. Now, let's say you have two burgers, okay? You have two burgers, but you have just one patty. So now what you will do is, you'll be able to form only one burger, right? Only one burger will be formed here with one tikki inside, but this will be the thing that is left over. The thing that is left over. So this usually happens in our houses as well. You must have seen your mother like literally crying for this one thing. My mother is like, why this is wasted? Why this is left over? Why don't you eat sabzi full on? Like, why you are doing this? Right? You waste things always. She's correct. She's obviously correct. Right? Because our mother don't want to have leftover things in the freezer. Right? That's what their main goal. Right? So, for example, you have rice, one plate rice, and you have just one simple bowl of, let's say, rasam, right? Now, we know that full plate of rice we won't be able to eat with some very small amount of rasam. That means you have some extra rice there, right? That means rasam is in less quantity, right? In this case, if I see, you talk about burger and patty, from if you have this 2 burgers and 1 patties, you will only be able to make 1 full-fledged meal here. That means this is your leftover, this is the extra, right? This is the extra thing that you have. Burger is the extra thing, right? Now, in chemistry, we don't focus on what is extra. We focus on what is less in quantity. In this case, because of this patty, this is the villain, this is the main villain. Burger is in 2 quantities, right? Patty is in just 1 quantity. Because of this patty, it's like you and your friend, okay? Your friend has just visited you, right? Surprise visit to your home. And your friend is like, I want to eat a burger, right? Now your 2 friends have visited. You're like, okay, 2 burgers I need to make, right? You have 2 burgers, but you have only 1 patty. What you will do? You will only be able to make 1 patty. So who is the culprit here? Culprit is patty because we have patty in less. The one which is in less quantity, that is the limiting reagent. That is the limiting reagent. Got it, students? What is access and what is the limiting reagent? Yes, everybody? Okay. Yes, everybody, beta, don't spam, huh? So, everybody, that is clear. What is a limiting reagent, right? Now, let's talk about this limiting reagent in one more example. Let's say we are talking about hot dog and buns, right? Similarly like burgers. Now, here you have 1, 2, 3, 4, 5 hot dogs, right? And you have 1, 2, 3, 4 buns, right? So the one which is in less quantity, because for 1 hot dog you need 1 bun. Understand one thing. For 1 hot dog you need 1 bun. So that means this bun is in less quantity, that is just 4. So that means what you will do, hot dog in a bun, like full-fledged meal, what you will have, this hot dog 1 bun, this hot dog 1 bun, this hot dog 1 bun, this hot dog 1 bun. And this particular hot dog will be the excess reagent and this will be your full-fledged meal. That means the limiting reagent is the one which, because of which we are not able to complete that reaction. Okay? Yes, everybody? Right? Limiting reagent is that particular reactant in a chemical reaction because of which we are not able to fully consume the other reactant. Okay? So let's take an example in chemistry as well. Let's understand this. So in chemistry, how we are going to understand? Let's say you have A and you have B. Okay? Let's say you have A and B. This is forming C. Right? If I am saying that this is the limiting reagent, I'll also tell you how to find it out. I'll give you a trick based on that. Right? So if I am saying that this is the limiting reagent, then can I say because of this reagent, I am not able to use B fully because this is in excess. Because of because of the extra hot dogs, right? This becomes the, see here what happened, because of extra hot dogs, this is in limiting. That means this is in less quantity, right? So the limiting reagent is the one because of which product formation is less. That means, can I say that it will depend on the limiting reagent that what will be the product formation? Let's say if here I had 5 buns, then I would have made 5 hot dog in buns, right? That means the overall product would be more, right? So that means it depends. If I say that here you have just this thing, let's imagine that here you have just 3 just 3 buns. So in that case, you will be able to make just 3 hot dog in buns, right? So that means the full meal, you need both the things. To form the product, you need both the reactant, right? So it depends on the limiting reagent, how much quantity of product will be formed, right? So this is a very, very important thing in terms of your numericals. When we will use the numericals, write it down here. Product formation depends on limiting reagent. Depends on limiting reagent. Okay, the product formation is going to depend on the limiting reagent, how much limiting reagent you have. Okay, this is a very important thing. Now, see, this is the base I am forming. Limiting reagent is not a theoretical topic that, okay, you know these points, okay, done. Nothing like that in physical chemistry, okay? Don't have this assumption. Theory I am teaching you just for the base, that you understand that what we are going to do in numericals. We have like plenty of numericals to solve in today's session, so that different types of numericals I have taken, so that you apply this concept also. But for that, you have to understand that product formation will depend on the limiting reagent. Now, let's see what is the trick. Okay, chalo, let me firstly tell me one thing. Chalo, firstly let's do the trick only. Okay, firstly let's do this trick, right? That will be useful in your like every single question you will do this way, because the biggest problem that students face is, ma'am, how to find limiting reagent? In one burger you have one bun, right? So it's easy to find the one which is in less quantity will be limiting reagent. But in chemical reaction, where you have things like this, 3 of A plus 4 of B give rise to 3 of C. Now 3 moles of this reacts with 4 moles to give 3 moles of this, right? It's like in one burger, you can have 3 patties, you can have 2 patties, you can have 5 patties depending upon different type of people, right? Now, for this thing, how do you solve the limiting reagent? One thing is do the unitary method, but that will be very lengthy. Let's not get into that, right? Simply what we will do, right? Simply what we will do, and this is going to be very beneficial for you, right? Let's say you have A and this is B. Give rise to C. I am assuming that this is 2, this is 3, and this is 1. Okay, this is the assumption, random assumption. Now, you have 2 things. One is given moles, other is stoichiometry, right? So, if you talk about given moles, let's say given moles of, moles I am talking about, moles, right? So, let's say given moles of A is given to be X, given moles of B is given to be Y. Okay, and here also if you say that, ma'am, please, we want a general reaction, then I'll give you a general reaction. Let's say here the stoichiometry is small a, here the stoichiometry is small b, here the stoichiometry is small c, right? Now in this case, stoichiometry is going to be A and B, right? This I am only talking about the reactants, right? Firstly, you will write this thing will be given in the question. Okay, this thing will be given in the question. Okay, this you will get to know from the balanced reaction. From the balanced reaction. Okay, one is your balanced reaction that will give you the stoichiometry that is there. One is in the question they will give you what is the number of moles of the reactants, right? Now here, simple thing how you will find out the value of limiting reagent. You will just use G divided by S. GS, that's it, right? Not SG, it's GS. Okay, so given by stoichiometry, G is X, this is A, this is Y, and this is B. And you know what? After solving, the one which has very important lower value of G by S is your limiting reagent. Okay. The one, ma'am, one example, multiple examples I'll give you. Okay. Firstly, we will solve the questions. No, in the questions you will see the examples only. Right. First, just understand this method. What is given? What is stoichiometry? Stoichiometry you will calculate from the balanced chemical equation, right? And given is that will be given in the question itself. That I'll tell you how it will be given in the question. So you solve G by S. The smaller value is your limiting reagent. Okay. The smaller value is going to be your limiting reagent. Let me know if that is clear to all of you or not. Right? This is the method of doing limiting reagent questions in a simpler way. Right? Otherwise, you end up, getting confused in this. Now, another question for doing numericals is, after this, we'll start doing the numericals. Another question is, ma'am, how I will know whether the question is of stoichiometry or limiting reagent? Because for limiting reagent, you have to apply this trick. You can't apply this trick for stoichiometry. You will apply this trick for limiting reagent. Okay. So, see, one thing is in the question only they are asking you what is the limiting reagent. In that way, it is simple, right? But what if they are just telling you this is A, this is B, this is C. They are asking you to find the mass, volume, moles, anything of the product. Now, ma'am, same thing we used to do in stoichiometry also. Same thing we used to do in stoichiometry, na? Reaction was given to us, right? And they used to find, in the last lecture, we have done this stoichiometry, right? They have given you some chemical reaction. They used to ask that what is this mass of this product, volume of this product and all these things. That was in mole concept stoichiometry. So what is the difference? Difference is in stoichiometry, one of the reactant, at least one of reactant, this is a hint, okay? One of reactant, here I am talking not about reactant, I am talking about the mass, volume, all these things, right? At least one of the reactant is missing. One of the reactant values is missing. I will tell values, okay? Values is missing, okay? At least one will have missing. Like, okay, they have given you A plus B, right? They have given you A plus B give rise to C. They will give you the moles of A. They will ask you the moles of C, right? Here we need only one reactant. In stoichiometry, we need only one reactant. That means we need means when I am talking about need, given I am talking about the mass, the volume, the particles, the moles, all these things should be provided for just one reactant. That's sufficient for us, for our stoichiometry, right? So in your stoichiometry based reactions, you are provided with not all the reactants, like all the reactant moles, everything is given for all the reactants, right? It is not there in stoichiometry, it is there in limiting reagent. So in the limiting reagent, what you will see, the values of all reactants is given. Or I would say instead of writing values, should I write moles? I think moles will be a better way, right? Because with mass also you can calculate moles, volume also you can calculate moles, with the anyways, right? Different formulas of calculating moles you can easily calculate, right? If they have directly given you moles or they are giving some formula where you can calculate the moles, two things, okay? So in stoichiometry, only, or you can say at least one reactant moles are missing, or you can say only one is given to you, that is also fine, okay? We need only one mole here, 1 reactant mole. But in this case, all the moles of all reactants, is given. Now, when I'll show you the questions, you will see for yourself. Then in all the cases of limiting reagent, reactant moles are always given to you. Every single reactant moles are given to you. Okay, is that clear to everybody? Right? Now, shall I start with the questions or not? Right? Okay. Okay. Are Vasuki, let's not get into spellings here, please. Okay. Chalo. Let's, mole is godfather, yes. Mole is mummy. Mole is mummy of everyone, right? Whenever you're in trouble, you always call moles, help me out, right? So let's see this. This is a question of JEE Mains 2022. Let's solve this question and you will see, ma'am, such a simple question. Huh, ma'am? Yes. So this is N2 plus 3H2 give rise to 2 NH3. That is your Haber's process. Now, mass of C. First thing is they have given you, this is the reactant, and for both the reactants, they have given you a hint to calculate the moles. So first thing is, in the case of limiting reagent, what you need to do, everyone? You need to find the moles of reactants. Moles of N2, moles of H2. So what is the moles of N2? That is going to be, mass is given to be 20, this is 28. This is given to be, a mass is given 5. And here, molar mass of one H2 molecule. What is the molar mass of one H2 molecule? 2 into 1, 2. Right, so it will be 5 by 2, that is 2.5. And here it is going to be 2, 10, then 2, 1, 4. This is 5 and this is 7. So it will be 5 by 7. I am going to write it like the same way. Okay. So it is going to be 5 by 7. Right. Number of moles of N2 is given to be 5 by 7. This is 2.5. Right. Now let us see. What I would advise you, write this also as 5 by 2. Okay. I'll tell you why we are doing this. Okay, because we need more, we need to add and subtract more here, divisions more we need to do, right? So now, the same trick that I told you to apply, that is N2 plus, firstly let us write the reaction here, right? Let's divide this into 2 parts, right? This is N2 plus 3 of H2 give rise to 2 of NH3, right? That is your reaction, right? Now tell me what is given to you. What is given to you? Given moles are 5 by 7. This is 5 by 2. So can you just write the given moles? This is 5 by 7. Is this 5 by 7? Yes, it is 5 by 7. It is 5 by 2. Okay, this is 5 by 7. This is 5 by 2. Right? What is the stoichiometry? Can you tell me what is the stoichiometry? This is stoichiometry is 1. Here stoichiometry is 3. So can I just divide it here and can I write it as what is the value of G divided by S? That is nothing but here 5 by 7. Here it will be 5 by 2 multiplied by 3. That is nothing but 5 by 6. Now tell me which thing will be smaller. See, you don't even need to calculate this. Do you need to calculate the value? If you have 5 that you divide this into 7 parts, that will be smaller. Each part will be smaller. If you have 5, you divide it into 6 parts, then each part will be larger. So which value will be smaller? This value will be smaller, right? This value will be smaller. Now can I say what is our limiting reagent? So N2 is limiting reagent. N2 is your limiting reagent, right? Limiting reagent done. Okay, easily you have calculated the limiting reagent, right? If you have any problem in calculating the limiting reagent, you can let me know in the chat box, right? because when we will move ahead, you will have more tough questions, then you will face difficulty, right? So I don't want you to do that, right? Instead, at every step you can ask me the question, okay? So this N2 is the limiting reagent. Now, if you see N2 is the limiting reagent, I told you one thing, that every single product depends on the limiting reagent. Let's see what is asked in the question. Consider the above reaction, the limiting reagent of the reaction. We have find it out, that is N2N2. That means this is eliminated, this is eliminated. Okay, number of moles of NH3, that you have to find out, right? Now, formation of product depends on the limiting reagent, that I have told you that this thing will be useful for you in your numericals, right? Product formation depends on this. Okay, can I say, now I will apply unitary method, that 1 mole of N2 gives you 1 moles of N2 give you 2 mole of NH3, right? Okay, so if you talk about what is the number of moles here? 5 by 7. So you can just write down here. Then 5 by 7 mole of N2 will be 2 into 5 by 7 of NH3. That will be the answer here. That is 10 by 7, right? So moles of NH3 produced, because in the given question we have just 5 by 7, right? Okay, so what is the answer here, everybody? Let's check out the answer. 10 by 7, 10 divided by 7, that is going to be 1.42 is going to be the correct answer here. You can calculate it, right? And you will have your answer here. Is that clear to everybody or not? Do we take limiting reagent or excessive? Ma'am, for unitary method, limiting reagent is taken. Okay, limiting reagent is responsible for the product formation. Okay, so that's why limiting reagent is taken here. That is clear to everybody here or not? Ujjwal, Bhuvan, Koma, Abhijit. Okay, yes. Array, you put it equilibrium here. Don't get into that, okay? So, that's fine, everyone. Right, so answer will be C is your correct answer here. Let's move towards the next question that was asked in JEE Mains 2025 question. Let's focus on that, right? Okay, Rama Raju, same concept will be repeated here. Okay, you can again, it's like every question you have the same concept. In first question, you might find it difficult. In second concept, it will be easy for you. But still, to just conclude it, what we have done here, they have given you reactants. Firstly, we know that to find the whenever product formation is asked and 2 reactants and the information about the moles is given to you, that is a question of limiting reagent. For limiting reagent, you need to find the number of moles of N2 and H2 from this data given. So I have find out the number of moles of N2 and H2. Now I know that given what we have calculated in the question is this and this that we have calculated here, that is the moles, right? Then stoichiometry is 1 and 3 here. Then what is G by S? That is this and this. Smaller value of G by S is your limiting reagent. Product formation will depend on the limiting reagent. Now we know that 1 mole of N2 gives 2 mole of NH3. Then 5 by 7 mole of N2 will give you 2 into 5 by 7 mole of NH3, and that is going to be the answer here, right? Okay. Okay, very good, very good. Now let's talk about the next question here. Yes, very good. There is molarity. Awesome. Awesome, awesome, Abhijit. Very good. So let's see this. Okay, from molarity also you can find the moles. If you remember, what is the formula of molarity? Molarity is equals to number of moles divided by volume in liter. If volume is given in milliliters, right, then you multiply it by 1000. Right, so that's how you can calculate the number of moles. Okay, so that's what I told you. Information directly either moles will be given to you, but JEE is not that easy exam, right? So they will not directly give you moles, right? they will ask you to calculate moles from either molarity or volume or mass, like these things. Okay, right? Very good. Let's see this. This is the reaction that is given to you. Very carefully see this. Consider the above reaction. This is the reaction. What mass of CaCl2? This is what they are asking you, right? Will be formed if. Now, till now, I am not sure whether this is a question of limiting reagent or stoichiometry. I am not sure about it. Which will make me sure whether this is a question of limiting, because can you see in the question anywhere they written limiting reagent? Anywhere they have never written formed will be this and this. Nowhere it is written limiting reagent. So that's where students get stuck. Ma'am, is this a question of stoichiometry or limiting reagent? Okay. For that, understand that if both the reactants mole you can solve from the question, then it is a question of limiting reagent. If you can't solve, that is a question of stoichiometry. Okay. See this. Consider the above reaction. What mass of this will be formed if this volume and this molar of HCl, that means for HCl you can calculate the number of moles, reacted with this much gram of CaCO3. See, information for both are given. So is this a question of limiting reagent now? Can I confidently say that this is a question of limiting reagent? Two reactants, both we can calculate the number of moles. Now, can I confidently say that this is a question of limiting reagent? Okay. So now we will solve this. Okay. So first thing is, let us solve the number of moles of CaCO3. That is mass by molar mass. Given mass is 1000. That is given to you. Right. What is the molar mass of CaCO3? That is 40 plus 12 plus 16 into 48. That is going to be what? 100, na? 8, 9, 10. 8, 9, 10. So I just solved it in front of you. CaCO3 is nothing but 100, right? So calculate this and you will get 10 moles here. 10 moles of CaCO3. Okay. Now let's solve the number of moles of HCl. What is the number of moles of HCl, everyone? What is the number of moles of HCl? Everyone, let me know. Moles of HCl. Simple. Ma'am, number of moles of HCl is, can you see this? Number of mole formula will be molarity into volume in milliliter divided by 1000. So now, here molarity is nothing but that is 0.76 multiplied by volume in milliliter, that is 250 divided by 1000. Right? Is that clear to everybody? This will be cancelled out. This will be nothing but 4 only. Right? Okay. So it will be 76 into 2 into 2. No, that will not be 2. Wait a minute. 76, this is cancelled out now. 76 by 400 will be the number of moles of HCl. You can just, if you take it out, 76 by 4. What is 76 by 4? You can also take it like this. 76 by 4, this is 1 by 100. What is 76 by 4, everybody? Everyone? Yes, 0.19. Very good. Right? So this is nothing but 19. So it will become 0.19. Okay. So that is the number. This is 10 moles. Here it is this much moles. Right? It is coming out to be this only. Yes. Now, see this. Definitely, even now we can clearly see which is the limiting, which is the excess reagent from the moles only. But still, we will have to solve it fully. So if you see this here, right, you have two things. Okay. Now, if you see, this is the question here, right? What is G? What is given? Given is this is for, let's say, CaCO3 and this is for HCl, right? Given for CaCO3 is 10 moles. So can I write 10 here? It is 10. Given is 10, right? Here it is 0.19. Okay, here it is 0.19. Now, stoichiometry is given to be CaCO3 is 1 and this is 2. So it is even lower than that. So can I say G by S is 10 here? This is 0.19 divided by 2. Now tell me which value is smaller here. Definitely this value is smaller. So can I say limiting reagent is HCl? Limiting reagent is HCl. Tell me, is there any difficulty in finding out which is the limiting reagent here? Right, everybody? Right? Okay. Are you able to find out which is the limiting reagent here? If you have any problem, same thing I have done, G by S, that I have find it out. That is your limiting reagent. Now, next is they are asking you which thing? They are asking you CaCl2. We know that this product formation depends on the limiting reagent. So we will apply unitary method here, right? We will say that 2 moles of HCl will give you 1 mole of CaCl2. 1 mole of CaCl2, that is from the reaction, from the chemical reaction, right? We are sure that 2 moles of HCl gives you 1 mole of CaCl2, right? Now, if you see, apply unitary method. Whenever we apply unitary method, we are like 2 moles give you this, 1 mole will give you this, that will be divided here. 1 mole of HCl will be 1 by 2 mole of CaCl2, right? Then, can I say that I want to find out how many moles of HCl I have? HCl mole is 0.19. 0.19 mole of HCl will give you 1 by 2 multiplied by 0.19 mole of CaCl2. Okay, 0.19, that will be 9 point, wait a minute. Achha, they have asked you the mass here, is it? They have asked you the mass here. They have not asked you this, they have asked you the mass here. Okay, so I'll just see, that is 0.19 divided by 2, right? It will be 0.09 something. 0.19, wait a minute, 0.19, 0.09, yes? So that is going to be 0.09 mole of CaCl2. I hope so we have not done any calculation mistake here, otherwise everything will be like ruined. CaCl2, okay, I really hope so. Let me just see that have we done any mistake here or not. This is 100, this is 10 moles. This is 0.16 molar multiplied by volume in milliliter, that is 250 divided by 1000, that will be 1 by 4. If you solve this, it is going to be less only. Okay, the variation is very high, na? That's why I was like little skeptical about it. Chal. Now, what is the mass? We know that number of moles is equals to mass by molar mass. So can I say mass of CaCl2 is equals to number of moles multiplied by molar mass of CaCl2. What is the molar mass of CaCl2? Ca is 40. This is for CaCl2. This is 35.5 multiplied by 2. That will be 30, 30, 60, 71, right? 70, 80, 80, 90, 100, 1, 1, 1. Is it? 7, 8, 9, 10, 11. So you added 1, 1, 1, 1 will be there, right? So multiplied by 1, 1, 1. Let's see, are we getting the right answer here? 0.09 it should be. 0.09, 0.09. Okay. Let's see, are we getting the right answer here? Yes, 10.54. 10.54 gram. Okay, that you will see. Okay, that will be your correct answer in the end, and you will solve this. You will get the answer. That is 10.54. That is C is your correct answer here. Students, tell me any problem in first 2 questions of limiting reagent? Any problem in first 2 questions of limiting reagent or not? right? Because we are going to solve the next question here, and that is also going to be very interesting question for you. So everybody, let me know in the chat box. Okay, let's solve the next question here. That is 8 liter of H2 and 6 liter of Cl2 are allowed to react. Everybody, clear or not? Right? Coma is again here talking about this and that. Fully. Oof, what I can do, guys? What I can do? All I can do is pray for your life, pray for your parents, pray for your good health, and pray that you earn something in your life. You get financially independent someday, because by doing nothing, you will not like be financially independent, right? Because competition, guys, is very high. Okay, so I can't do anything. I have given up, right? You want to chat, beta. No issue. And those who are thinking that Koma Kula, some people are thinking, oh my God, some girl is talking to me. I'll waste my career for that girl. Right? You have no idea whether that is a girl or who. Right? You have no idea who is that person with a fake ID who is talking to you. So just chill, relax, and focus here. Right? So now 8 liter of H2 plus Cl2 are allowed to react to form HCl. Okay? This is the chemical reaction. Right? Now they are saying 8 liter. This is 8 liter. This is 6 liter. Right? Of Cl2 are allowed to react to maximum possible. Find out the final volume of the reaction mixture. See, firstly you have to find out the limiting reagent here. Okay? To find out the limiting reagent, simple thing is, if you see the number of moles of H2 here, I'll just calculate it here. Number of moles of H2 will be given volume by 22.4, right? That is the molar volume. Number of moles of Cl2 will be given volume by 22.4. I'll not solve this, I'll take it as it is. Okay. Now, if you see this, given is what? Given is what? This is 8 by 22.4. This is 6 by 22.4. Stoichiometry is 1 and 1 here. Can you see which is the smaller value here? Which is the smaller value? Because you are dividing it with the same factor. Here larger number is divided by the same factor. Here smaller. What is G by S? What is G by S, beta? G by S is 8 by 22.4. This is 6 by 22.4. Now, when the larger value is, it's the same thing. If you have 10, if you have 5. This is also divided by 2. This is also divided by 2. This will be the smaller value. Why? If the smaller value, they are divided by the same constant, right? That is 22.4. If smaller value is divided by the same constant, that will be the smaller value, right? So answer is going to be, this will be smaller. So now tell me, what is the limiting reagent here? What is the limiting reagent here, students? Limiting reagent is Cl is the smaller value. Very good. Cl is the, Cl2 is the limiting reagent here. Cl2 is the limiting reagent here. Limiting reagent here. Can I like confidently say that Cl2 is the limiting reagent? Right? Now, when we know that Cl2 is the limiting reagent, after that we are going to think that, man, what next we should do? They are saying that H2 and Cl2 are allowed to react maximum possible extent. Find out the final volume of this. See, now see this thing very carefully, okay? I know that 1 mole of this reacts with 1 of this to give 2 of this. Okay? Right? That means, can I say that 1 mole means 22.4 liter? See, 1 mole means what? Given will be 22.4 because molar is 22.4. Only then you can have 1 mole, right? So if I am saying 1 mole, that means can I say 22.4 liter? I'll just write it like this. Okay. Can I say 22.4 liter of H2 reacts with 22.4 liter of Cl2? That means if you are using H2 as 22.4, Cl2 will be 22.4 also, right? Or if you don't want to get into this, you can just simply write the same thing here. Let's say we know that Cl2 is the limiting reagent, Cl2 is 6 liter. So product depends on Cl2. Okay, so you can just directly write that 1 mole of Cl2 gives you 2 mole of HCl, right? How many moles of Cl2 you have calculated here? That is 6 by 22.4. 6 by 22.4 mole of Cl2 will give you 2 into 6 by 22.4 mole of HCl. I am not solving this. I am just writing this in the same pattern. Okay. I don't want you to, usually what happens, students get confused. They follow different methods. Right. So I am following the same method. Firstly, you solve the limiting reagent. Then we know that for the product formation, it depends upon the limiting reagent. I'll apply the unitary method that 1 mole gives 2. So this much mole will give you this much mole multiplied by 2. Right. Now, calculate the volume, because in the end, they are asking you not the moles. They are asking you find volume. So you have to write everything in volume. So that's why I have not done any division calculation. I have not done here. Right? Now I will say that, I'll simply say that HCl formed is, see, we know that number of moles of HCl is equals to volume of HCl divided by 22.4. Number of moles of HCl we have calculated is 2 into 6 by 22.4. This is volume of HCl divided by 22.4. This will cancel out, and volume of HCl in reaction for given data is 12 liter. Till here, is that clear to everybody or not? 12 liter of HCl tool. Very good, Aman. Very good, Arun. Sorry, very good, Arun. Very good, excellent. Excellent. So, volume of HCl in the reaction is 12 liter. But see one thing. In this reaction, this was given to be 8, this was given to be 6. So 6 liter has reacted because this is the limiting reagent, but here when you react 6 liter, you are left with 2 liters here. So total volume left is 12 liter plus 2 liter. This 12 liter is of HCl and this is of remaining H2, right? You can write remaining H2. So answer will be 12 plus 2, that is 14 liter is the correct answer here. Okay. Okay, Abhijit. Beta, in that way, if you're like doing like orally, you are doing this, then you have to be pro in this. Okay. So that's why first you try to do this way. Orally also you can do this. You know how you can do this? Simple thing is you can just see this here. This is the limiting reagent. That means 6 volume will be consumed. So 6 liter of volume will be consumed. This is 8 liter, right? 8 minus 6 is 2. And this is 2 liter is left here. And here if 6 liter you are using, this is double of this is formed. That means here you will have 12 liter. Because molar volume is constant. If the molar volume is constant, then you don't need to worry about calculating moles every time. But I have used the same pattern here so that you don't get confused. Otherwise, you can do this orally also if you have practiced enough questions here. Only then. Okay? Yes, everybody? Very good. Awesome. Awesome then, Abhijit. Awesome. But your answer is coming out to be 12. It should be 40. Okay. 12 is for this one and 2 is for remaining H2. Okay. Okay, ji? Yes. I'll just recap this for you. See, this question was given to us, right? They have asked you the volume in the beaker, right? Volume in the beaker of the gas will be the product that is formed if some of the reactant is left unreacted, right? So for that, because everything about the reactant is given to us, so firstly, that means this is a question of limiting reagent. We'll follow the same process. First, we will solve number of moles of H2, then we will solve number of moles of Cl2, then we will solve G by F, and this will become your limiting reagent. That means Cl2 will give you the formation of HCl depends on Cl2. Then you will apply unitary method that 1 mole of Cl2 give you 2 mole of HCl, this much mole will give you this much HCl. Mole of HCl, now you know that how much is produced in the reaction. From mole of reaction, mole you can apply the formula of volume here, right? That means mole in terms of volume, you can get the volume of HCl, not in terms of moles I am asking, in terms of HCl. That means in this reaction, if you use 6 liter, this is 6 liter, this 12 liter is formed. And here we have given 8 liter. So out of this, 6 liter is using 6 liter only. So that means here you are left with 2 liters. So this 2 liter plus this 12 liter is the remaining volume of the gas in that beaker. So that's why answer is going to be 14 is the correct answer here. Okay. Plus 2 we have added because let's see here, this is the beaker. Here you have some H2 molecules and here you have some Cl2 molecules. Okay, Cl2 molecules. Now, what is happening? Cl2 is actually not your limiting reagent, so full Cl2 is consumed, right? But 2 liter of H2 you are left with, right? Which is unreacted, which is the excess reagent, and you have the formation of HCl. So now after this reaction, you have HCl that is 12 liter, and you have 2 liter of H2 that is unreacted. Okay, right everybody? Equivalent weight we will do in the next class. Okay, in the next class we are going to do equivalent weight, POAC, all of that we will do in the next class. Okay, is that clear to everybody or not? Right students, if that is clear, then let me know in the chat box, because we are going to start with the next question here. I think 2 questions we have and very interesting questions we have for limiting reagent. Okay, let's solve them as well. No issues, Ria, no issues. Okay. So, let's solve this question of JEE Mains 2022. Okay, let's solve this question, everybody. So the question says that production of iron in blast furnace follows the following. This is your JEE Mains 2022 question. You can see I have picked out previous year questions only, right? And they are repeated. So you can't ignore this topic, right? Okay. Production of iron in the blast furnace follows the following equation. This is the equation that it is following, right? So equation is given to you, that's good for you, right? Now, when this much kilogram of Fe3O4, beta, this is Fe3O4, okay? It's like this, right? So I'll just rewrite this. It is actually Fe3O4, so it should be written like this. Read out the full statement here. Read out the full statement. Read out the full statement. Fe3O4. Right? And those students who have just joined, right? Don't worry, I'm going to finish off this topic. We are going to start with empirical formula that has no link with limiting reagent. Okay? So, at least understand empirical formula after this. Right? After 5 or 10 minutes also you can join those who have not watched the full lecture of limiting reagent, right? Because you can re-watch it after I finish the class, right? If you have not watched the basics of limiting reagent, then this will be very difficult for you to continue and understand this particular question, okay? Production of iron in a blast, in a furnace is this. When this much of Fe2O3, that means we can calculate the moles of Fe3O4. and this much of CO, that means can we calculate the number of moles of CO? Yes, ma'am. Are allowed to react, then the amount of iron in grams is. This is what they are asking you. Now, who will tell me firstly what we have to calculate? Firstly, tell me, is this a question of limiting reagent or not? Right? Okay. Okay. One more lecture. Right? Yes. What is very good, very good, very good. First, you have to calculate the number of moles of Fe3O4. Then you have to calculate the number of moles of CO, right? Given mass by molar mass. So given mass will be this multiplied by 100, right? So that will be 4640 divided by molar mass. This will be 2520 because this will also be divided by 1000, multiplied by 1000 here, right, to get the mass in grams. Okay. Now what is the molar mass? Molar mass, you will say 56 multiplied by 3 plus 16 multiplied by 4. That will be the molar mass. And here it will be 12 plus 16. So it is 678. This is 28. So this is going to be the molar mass here, right? What about the molar mass in this case? Let's not waste our time in that. Better in exam, you have to do this, okay? So this will be 232 grams. After solving, you will get 232 grams, okay? After solving this, you will get the number of moles after dividing it is 20 and this is coming out to be 90. So I'll just directly write this here. This is coming out to be 20 moles and this is coming out to be 90 moles. Okay, this is coming out to be 90 moles, right? Okay, now this is in grams, this is in grams, moles we have calculated. Now can you tell me what will be the next task here? Who will tell me what will be the next task here? Who will tell me what will be the next task? To find out the limiting reagent here. Now, how do you find out the limiting reagent? Given by stoichiometry you have to do, right? So, this is Fe3O4 and this is CO, right? I will firstly write what is given to you. Here, Fe3O4 is 20, that is 90. So, I will write 20 and this is 90. And stoichiometry, can you see? Fe3O4 is given in the reaction, this is 1, this is 4. So can you see stoichiometry is 1 and 4. So can I write 1 and 4 here? Then after that, when I will calculate G by S, here it will be 20 by 1, right? Here it will be 20 by 1 and this will be 90 by 4, right? This will be 20 by 1. 90 by 4 will be greater. See, 90 by 4 will also be greater than this. It will be 20 point, wait a minute, that will be 10, 10 divided by 4, 2.5. I think 22.5 it would be. Is it? 22.5 it should be. 90 divided by 4, yes, 22.5. Okay, so answer will be 22.5. Now, after that, what we are going to do, tell me which is the smaller value. You don't even need to calculate this, right? You just have to get an idea which is larger and smaller. So we know that this is the smaller value. Now tell me which is the limiting reagent. Which will define the limiting reagent? Very good, everybody. Which will define the limiting reagent? Limiting reagent is going to be Fe3O4. So can I say that Fe3O4 is your limiting reagent here? Now students, once you have solved the limiting reagent, then let me know in the chat box what is the next step. What is the next step? They are asking you, are allowed to react the amount of iron in grams. That means moles of iron you have to calculate. So we know that iron depends on the limiting reagent. Okay. We know that iron will depend on the limiting reagent here, right? So limiting reagent is what? What is the limiting reagent? Limiting reagent is Fe3O4. So can I say 1 mole of Fe3O4 give you 3 moles of Fe? 1 mole of Fe3O4 give you 3 mole of Fe, right? Then how much moles you have here? Number of moles are 20, right? 20 moles of Fe3 will give you 20 into 3 of Fe. That means 60 moles of iron will be formed here. But have they asked you in moles? Amount, that is to react to amount of iron in grams. That means they are asking you mass, right? So we know that mass is equals to number of moles of Fe multiplied by molar mass of Fe. Number of moles is 60, molar mass is 56, and you will get the mass of Fe here. Right, everybody? Right, everybody? Very good. Abhijit, 3360 is the correct answer here. Right? You solve this and you will get your answer here. That is 3360 will come out to be the correct answer here. That is C is your correct answer here. Clear, everyone? Now, last question of limiting reagent that we are going to do. After that, we are going to start with empirical formula, which is actually a very simple topic, right? So let's do last question of limiting reagent, okay? This question might be little difficult for you, right? So you have to see this question very, very carefully, right? Each step I'll tell you. Firstly, I'll tell you what they are telling you in the question, okay? I know that most of you will say that, ma'am, please repeat. I know that, right? So that's why every single step I'll ask you. If that is clear, you have to tell me in every single step when I'm asking you, and full concentration has to be here. Okay? Yes, everybody? Full concentration should be there on the board. Okay? Let's see. First, let's see what the question is saying, right? They are saying that one, don't get into what is given, what purity, ignore. First, just see what is happening in the reaction, what is happening in the question. Okay, 1 gram of sample of CaCO3. Okay, you have CaCO3 was strongly heated. So we know that whenever it is heated, you have CaO and CO2 is formed. Okay, it was strongly heated to give CO2 was liberated, absorbed in this. Now the CO2 that is liberated is absorbed in NaOH. After this, what will be formed in NaOH? Right? We know that here you will have the formation of when you have Na2CO3, right? Okay, plus water will be formed here, right? This reaction, you should know that carbon dioxide, which is acidic in nature, reacts with the base to form salt and water, right? Then they are saying reacts with NaOH solution. Assuming this, okay, that we can ignore. They have just told you to confuse you. We will use this, but right now just ignore that. How many milliliter of 0.5 HCl would be required? This line is very important. HCl now they are saying would be required to react with the resulting solution. Resulting solution, okay, to reach the end point of the presence of phenolphthalein. Beta, tell me, it's a very, very important question, okay? So see, what is the end point of, tell me one thing, when the end point of phenolphthalein is reached? When the end point of phenolphthalein is reached? End point of phenolphthalein is reached when full acid and base, they all combine together, right? That means all of acid is combined with, there is neutralization, right? Full acid is reacted with full base. That is the end point of phenolphthalein. That means this HCl that you are adding here would be required to react resultant solution to reach the end point of this. That means that should react with full of NaOH. Now see, HCl reacts with base. Okay. Can you see here you have some carbon dioxide that is liberated. that carbon dioxide is used with some NaOH that you already have. Okay? Firstly, we have to see that this acid that we are talking about in the end, that will react with two things. If there is any NaOH left, or if there is or the base, that is Na2CO3. Tell me if that thing is clear to you, that in the end, right, ma'am, what is the end point? For that you have to see redox reactions, right? Till now just understand that we have to react full HCl with full NaOH, right? Not even 1% HCl should be left behind, okay? Full HCl should be consumed with any base, right? Now we have two things here. If there is some NaOH left or there is some Na2CO3, these are the two possibilities which can react with HCl, right? Now I know that still you are not that much clear on this, but just wait, have patience, okay? One by one I'll teach you, right? First thing is, first reaction, okay? First thing that is given to us, firstly let's CaCO3, let's firstly talk about this reaction. This on heating will give you CaO plus CO. See, we know that 1 gram of sample of this was reacted with this much. And they are telling you assuming 90% purity of the sample. This means CaCO3 is 90% pure. And we are talking about only the pure sample. Impurities will not react with the impurities will not be heated. See, you have 1 gram sample out of which only 90% is CaCO3. Rest of it is impurities. So only the pure sample will react. Okay, so that's why mass of CaCO3 will be 90% of 1 gram. That is 90 by 100 of 1 gram, that is multiplied by 1. That will be nothing but 0.9 grams. Tell me if that is clear to everybody, that what is the mass of CaCO3. Students, is that clear how to calculate the mass of CaCO3? Now, we know that moles is something that saves us every time, right? So, if we have to always deal in moles, okay? So, we will calculate the moles here. So, now I'll calculate the number of moles. Number of moles of CaCO3 is 0.9 divided by 100, because 100 is the molar mass of CaCO3, right? So, that will be 0.009 gram. Oh, sorry, 0.009 mole. 0.009 mole. Tell me if that is clear to everybody. Number of moles of CaCO3 we have calculated. Now we know that CO2 is what we can use from this reaction. So how much amount of CO2 will be formed? If 1 mole of CaCO3 is giving you 1 mole of CO2, then 0.009, you will write 1 mole of CaCO3 gives you 1 mole of CO2. Then 0.09 mole of CaCO3 will give you 0.09 mole of CO2. So number of moles of CO2 formed is 0.0, it should be 009, na? Yes, it should be 009. 0.009, 0.009, 0.009 moles. Tell me till now total moles of HCl. Very good, very good, very good. Awesome. Right? Let's see this. Students, tell me till here any problem. We have calculated the number of moles of CO2. Right? Now some information regarding NaOH is also given to us. Let's see that what they are saying, that liberated was this, because see, this question is actually this particular reaction. Just give you this thing. This is NaOH. I'll just write it here. Now, beta, here you will apply the limiting reagent. this is where you will apply limiting reagent. This is where you will apply concept of limiting reagent, because you have solved the number of moles of CO2. Here, to calculate number of moles of CO2, they have not given you mass, they have not given you the molarity or something, but instead to calculate CO2 moles, we have calculated it from this reaction by applying stoichiometry, right? So that means from here we have calculated the number of moles of CO2. Now, if I am able to calculate the number of moles of NaOH, I will see that which is the limiting reagent, right? Okay, let's see this. Number of moles of NaOH was liberated, absorbed in 100 milliliter of 0.5. See, we know that molarity is equals to number of moles divided by volume in milliliter multiplied by 1000. So can I say that number of moles is equals to molarity into volume in milliliter divided by 1000? Can I say that? Multiplied, divided. So number of moles is equals to, number of moles is molarity. What is the molarity, everyone? Molarity is 0.5 and 100 is milliliter. So 0.5 divided by 1000 multiplied by 100. So you calculate this, it will be 0.05 mole. That is the number of moles of NaOH. Number of moles of NaOH. Okay. Till now, we have calculated the number of moles of NaOH. That was the number of moles of CO2. Both the things we have here, number of moles of this, number of moles of this. Can we start doing the, which is the limiting reagent? Everybody, which is the limiting reagent? Everyone. Yes. What is the limiting reagent? I'll solve it here, right? What is the limiting reagent? You already know the number of moles here. See, I'll just write the G and S here. This is given and this is stoichiometry, right? This is stoichiometry. Here I am talking about CO2 and here I am talking about, let's say here I am talking about CO2 and here I am talking about NaOH. Given is, the given number of moles of CO2 is 0.009 and this is 0.05. This is 0.009, this is 0.05. Stoichiometry, if you see the reaction here, in this particular reaction, you have you balanced it? We have not balanced it yet, right? Carbon is 1, this should be 2 Na, right? Oxygen is 2, oxygen is 3, oxygen is 2, 4, oxygen is 3, 4, hydrogen is 2. Yes, it is now balanced. Can you see? Now it is balanced. Everyone, don't do this mistake that you are solving. This is a very, very important question, okay? Right? Okay. Okay. Am I solving question with one reaction easily, but I feel difficult in question with multiple reaction. That is why you have to do question practice, right? That is why I don't bring out simple questions for you. I'll boost your ego with simple questions, but in the exam, you will be like, ma'am, why you did this to me, right? But when now you'll be like, ma'am, why you are doing this to us, ma'am? Please leave us, no, ma'am, please, ma'am, end the class. But in the exam hall, you will thank me that, ma'am, thank you for teaching us this question so patiently, because now you're in the starting phase, right? So that's why I take up questions which have multiple reactions also. So we know that I'll apply, we know that this is 1 and this is 2. So can I just write here, CO2 is 1, stoichiometry is 1 and this is 2. So I'll just apply this G by S. What is G by S? Everybody, now you have to tell me what is G by S. Here it is 0.009 by 1, that is 0.009 only. This is 0.05 divided by 2, that is 0.025. Now tell me, which is the smaller value? Which is the smaller value here? Right? Which is the smaller value? 0.009. So can I say that this is the limiting reagent? This is the smaller value. So can I say that limiting reagent, CO2 is limiting reagent. It will be, beta, limiting reagent is always fully consumed, right? You have two burgers, you have one patty, burger will be left behind, you will eat patty in the burger, right? So it will be fully consumed, right? You can write it will be fully consumed. You will consume it fully, you don't have to worry about that, right? It will be fully consumed. Next question. Tell me, beta, if till here it is clear, you will be like, ma'am, this much, ma'am, big question. Yes, this is what they ask you in the exams, right? This is the reality, right? Till here, if that is clear, now what is the limiting reagent? Now the main part. Till now, everything was easy. This was also easy. This was also easy. This was also easy. Till here, I assume that very rare students will do mistakes. But after that, students will start doing the mistake, right? Abhijit, in class 10, 9th, so obviously you will find these things difficult. Don't worry. You still have time. You will be able to do this very easily, right? So now CO2 is the limiting reagent. Can you see this? This is the limiting reagent. That means this thing will be excess. Okay? Now I'll see that with this much amount of CO2, I'll see that how much amount of NaOH is left behind. Okay? See this very, very carefully. If I see how much of NaOH is used here, how much NaOH is used, right? Can you see how much of, wait a minute, what is given to you is this much, right? Wait a minute. Number of moles of NaOH that is given to you in the question is 0.05. Now, I know that in the question, we know that 1 mole of CO2 will give you 2 mole of NaOH. 1 mole of two things you have to apply here. First, you have to see two things are base. This is also base, this is also base. It's a very important concept that this is also base, this is also base. So HCl will react with two things. One is the amount of NaOH that is left. Second is the amount of Na2CO3 that is formed. So both of them you have to calculate, right? So to calculate the amount of NaOH left, firstly I am calculating the amount of NaOH left. So I am writing this heading here to calculate amount of NaOH, so that after notes also you will be able to understand this. To calculate amount of NaOH left, first thing is 1 mole of, see this is 2, this is reacting with 2 moles, okay? So 1 mole of CO2 reacts with 2 mole of NaOH, right? In the question, we have 0.009 mole of CO2 that will react with 2 into 0.009 mole of NaOH, right? Okay, so that will be nothing but 0.018 mole of NaOH reacted. This much will react here. How much was there? Total NaOH is equals to NaOH, total NaOH minus NaOH used, NaOH reacted is equals to left NaOH. How much NaOH is left? Okay. So how much is the total? So you can say total NaOH is nothing but 0.05. Total NaOH you have used is 0.05. Okay. Now how much amount of NaOH that is reacted is 0.018. Now tell me beta, how much is left behind? 0.05 minus 0.018, that is 0.42, right? Okay, is it? Okay, wait a minute, 0.05 minus 0.018, that is 0.05 minus 0.018. 0.032 or 42. 0.05 minus 0.018, 0.032. It is coming out to be 0.032. Okay. Okay. I know till now you're like, ma'am, what is this question? See, you have to do this. What to do? Right? Level you have to increase. If you actually aiming for JEE Advanced, you have to increase your level. But these kind of questions, they can easily ask in JEE Mains as well. Right? So how much of this of HCl would be required to react with? See, we have to calculate how much of milliliter. We know that molarity is given to you. You need to calculate moles of HCl. How much of moles of HCl, only then you'll be able to solve this, right? Now, next is to how much amount of, can you tell me how much amount of NaOH is formed, Na2CO3 is formed? How much amount of Na2CO3 is formed? Amount of Na2CO3 formed. How much amount of Na2CO3 is formed? How much amount of Na2CO3 is formed? By this, you can just directly say that 1 is giving you 1. So see, what you will see, this is going to be simple, that 1 mole of CO2 gives you 1 mole of Na2CO3. So 0.009 of this is going to give you 0.009 of Na2CO3. So HCl will react with how much? HCl will react with how much? See, first will be the number of moles of NaOH left plus number of moles of Na2CO3. That is going to be 0.032 plus 0.009. But till here, if you have any problem, then let me know in the chat box. Till here, if you have any problem, then let me know in the chat box. Everyone, till here, if you have any problem, then let me know in the chat box. Okay? Mean mole concept before, mean mole concept after this question. Okay. So that is clear now. Till now, tell me if that is clear, right? Now see, the acid is going to react with NaOH as well, left NaOH and left Na2CO3 as well. That means it is going to react with how much NaOH? This much NaOH. So add this now, so you have already solved the question. Just add this. What will the answer here? 0.032 add 0.009. Okay, 0.041. 0.041 moles. See, because of the end point, the base moles should be equals to acid moles. Number of moles of base should be equals to number of moles of acid. So that's why number of moles of HCl is going to be 0.041 only. Right? Now you have number of moles of HCl. Now tell me what you are going to do. Number of moles of HCl you have. Now tell me beta what you are going to do here. Number of moles of HCl you have. Now tell me what you are going to do here. Right? Simple. Number of moles of HCl is given to be 0.041 moles. Molarity is equals to number of moles by volume in milliliter multiplied by 1000. Right? So volume in milliliter is going to be number of moles 0.041 divided by, for acid they have given you that for acid this much of molarity HCl will react. That means 0.5 is the molarity. So we'll put the molarity as 0.5. Okay? You can just write it here. Volume in milliliter will be equals to this by molarity, that is 0.5 multiplied by 1000. Solve this and you will get your answer. Let's see if we are getting the right answer here. Right? 82. Yes. We are getting the right answer, 82. Right? But this will be in milliliters. Right? See if they have given in milliliters only. Yes, they have given in milliliters only. So answer will be C is the correct answer here. Ma'am, I didn't understand this question. Those who have not understood this question, you will have to rewatch this, right? I'll just recap this, okay? Right? Okay, I'll just recap this. Okay, students? See, this is the question that they have given you. They have given you this reaction. They have given you, they are saying that CaCO3. See, main is your this reaction. Okay? They are saying that you have CaCO3, from that CO2 is liberated. That CO2 we are reacting with NaOH, and that is giving you Na2CO3. Now in that beaker, that is further reacted with HCl. Right? Now, what I calculated, I first calculated by stoichiometry, I calculated the number of moles of CO2. Okay, you can see this here. In this whole process, I calculated number of moles of CO2 by applying stoichiometry. Then after this, I calculated number of moles of NaOH. That was also data was given to me regarding that. So by applying formula, I calculated number of moles of NaOH. Now after applying NaOH and after calculating number of moles of CO2 and number of moles of NaOH, now you have to see, is there any limiting reagent, right? That's why I did this thing. Now I know that CO2 is the limiting reagent. That means CO2 will be fully consumed. That means NaOH will be accessed. And if you are adding base, if you are adding, acid, acid will react with this also and this also, because this is also base, this is also base. If we say there is no limiting reagent, then NaOH we don't need to think about, right? Because NaOH will be fully used. But here NaOH is not fully used. It is left in excess, right? So that's why I want to calculate that how much amount of NaOH is left. For that I calculated that how much amount of NaOH is used. Then I subtracted with the total number of moles. I have this, right? Now then I calculated by applying stoichiometry how much amount of Na2CO3 is consumed. Remember that everything depends upon limiting reagent. NaOH also I calculated from limiting reagent. Na2CO3 also I calculated from limiting reagent. Now I added the number of moles of Na2CO3 and NaOH that you are left with, right? NaOH left plus Na2CO3 is this. So base moles is equals to acid mole. From that we can say number of moles of HCl is the same. If you know the number of moles of HCl, right, after that apply this formula of molarity and you will get the volume of HCl. Okay, yes everybody. This question is very lengthy, that's why, right? For you in the starting it might feel actually it's very lengthy, but it's not that difficult. You can easily do that, right? Okay, now guys, let me know one thing, right? Shall we start with empirical formula? The class is like, students are like, ma'am, we can't do this question, right? They're like, ma'am, we need some rest. I have a thought of doing empirical formula also today. Achha, do you want me to do empirical formula in the next class? Right, because that is also equally lengthy. I don't know what is happening. I always make like, I always assume that this I can do in let's say this much time. This never happens. Right? Okay. You can vote for it. Now it shall do, ma'am. Okay, let's see if the class strength is more than at least 20 students, then only there is benefit of doing, na? Right? Let me see. Ma'am, Ujjwal, for class 11 syllabus, right? My class is today and Saturday, right? And for class 12, right? I think the session was on Monday, and that will be Thursday, Monday and Thursday. Okay, right? Okay, ma'am, please, I request you, ma'am, or it will be lengthy. Which? Okay. Let's see. I'm still waiting for the students to join in. I'm still waiting for the students to join in. I think the students are little tired of doing this. Then I'll do one thing. I'll do this in the next class only. Okay. I'll do this in the next class only. Let me see. Let's vote. Let's vote. Okay. If the vote is like more, then only I'll do it. Do it in the next session. Do it today. Mix. Let's see. Let's see. बेटा you है ना let's see if yes means do it in the today's class or otherwise in the next class. But there are very few students, so what do I will do, है ना बेटा? Even I need to have some energy in the class now to teach. Energy will be given by you students, right? So if there are very few students whom I will teach, right? Same you told me about stoichiometry. That took 1.2 hours approximately. You told me, ma'am, do limiting reagent also. Just imagine that if we would have done limiting reagent in the last week, now limiting reagent, this much detail, it's very difficult to teach in this much detail in just half an hour. Right? Same will happen to limiting reagent. Okay? So I'll do one thing. I'll do this on Saturday. Okay? 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 So I'll do this on Saturday, right? Because like, you know, I also want your energy to be there, my energy to be there, students to be there. Only then the flow of the lecture will be good. Right? Okay? Chal. Okay. Right. I'm so sorry. Right? Shall I go then? Ma'am, or do it in 8:30? I'm so happy that you guys are very excited for this, you know, you're very excited for the next lecture. I'm very happy about it that I'm teaching, you know, that way, that you are loving it and you want to study more. That makes me happy, right? Great, great, great. Okay. Okay then, beta. Abhijit, relax, beta, relax. Okay? Things we need to see a lot of things. Even I need to see that I need 2 hours to complete empirical formula and we don't have that much time. Your class of 8 p.m. your next class is going to start, right? So I'll do this in the next class. Okay, chal. Okay then students, bye bye. Homework questions. Okay, so I'll give you the homework questions here. Right, homework questions you have is, wait a minute, your homework question is okay, this is the homework question. Okay, very happy to see you guys are telling me, ma'am, please give us the homework question. So this is your homework question. How many moles of H2 are needed to react completely with 2 moles of N2, right? Moles of H2, and this you have to see whether this is a question of limiting reagent or this is a question of stoichiometry. By that you have to solve this. Okay, let's see if you're able to identify that or not. Okay, ji, chal. Okay then students, bye bye, take care. And before going, one very, very important news for all the students out there, that right now one very important offer is going on, in which in the pro batch of JEE 2027 students, you can see this here, 2-year JEE course, and that is in the online format. But in this, you will have like a proper mentor, dedicated mentor. It's like you are in the offline center only, but you are through camera, right? It's just that I am also able to see you, you are also able to see me. Now you are only able to see me, but in this particular thing, I will also be able to see you, right? Okay, so that would be a great thing for all of you. And you can, you know, you're always unmuted. So you can anytime you can just raise your hand and ask the doubts in the class, right? Just like you do in the offline centers, right? Now, This is for all the students who just don't want to take the hustle of going into offline centers, or maybe offline centers are not nearby them, but they don't want that they should lag behind. So that's why this is very important. And moreover, this is for those students who are very less disciplined or not consistent, right? You always make timetable plans, but you're not able to follow that, then this is the batch for you, in which proper timetable, schedule, mentor, PTM, parent teacher meeting will be done, right? Your analysis, your proper counselor, dedicated counselor will be given to you. Doubt solving, 24/7 doubt solving app will be provided to you, where you can 24/7, any time of the day, you can call the teacher and you can ask your doubts, right? Because the major problem is that we are practicing a lot for JEE, but for that we also need someone to answer our doubts, right? So 24/7 that is available, because we know that some students are morning persons, they are like wake up at 4 a.m. and they will study. Some students study at night, right? So everything is provided to you here. And hard copy of books are delivered to you, QR cards are delivered to you, short notes are prepared for you. Everything is done in the batch itself, right? Okay. ठीक है जी, चलो. Okay. Okay then students, and here this is for your those who are in JEE 2020 preparing for JEE 2026. This is the batch for pro batch for JEE 2026, right? Okay, and for all the droppers out there, we have Sigma JEE batch for 2026, right? But here you will see this is, it's like in the Sigma batch, this is for those students who want to, like, who are droppers or in the 12th class, and they are self-disciplined, like they don't need every single time any mentor or anything, right? They are self-disciplined, they are consistent, they will attend the classes regularly. And for these students as well, mock tests are provided, live classes are provided to you, doubts are solved in the class, and even in the replays you have doubt solving. So depending upon that, everything is there. Test series are provided to you, QR cards are provided to you here as well. And in this also you have different variants, where you can see the course plans here. Different variants are there, in which one you have quick revision cards are available to you, in one you have Tatva JEE, and 12 books are provided to you. So different variants are there for this batch. Okay, chalo. Okay then students, bye bye, take care, see you all in the next class, bye bye.